All right, so I had some questions about chi-square. Chi-square is just a way for us to analyze our hypotheses and decide whether or not we will accept or reject our null. So the formula for chi-square, and chi is just a Greek letter x, is the sum or sigma, sum of, observed minus expected squared over expected. Okay, so let's say that we have 40 ants. Not my favorite critter, but we'll go with it. And we want to know if they have a preference when we offer them banana or honey, because that's kind of like nectar in a flower. Maybe give them some grapes, because that's a sweet fruit. And then something not sweet, let's go with lettuce. Okay? And so we want to know, do these 40 ants have a preference over these foods? Well, before we do our experiment, we want to write our hypotheses. So let's come up here and write our null. So our null is going to be that the ants have no preference of food choice. Okay, ants have no preference. They don't care. They just eat whatever. The alternative, you can write, there's actually 5 different alternatives for this one. I'm just going to write a non-directional. That is that the ants do have a preference. We may not know what that is, but we're going to say they have a preference. You could also say that they prefer, if you wanted to go directional, you could say they prefer bananas, or you could say they prefer honey, or you could say they prefer grapes or lettuce. So that would be one potential, 2, 3, 4, 5 different hypotheses you could write, and any of those would work. All right, so we have our hypotheses. We don't know our values yet, but we can go ahead and figure out our expected because we know our total number of ants. So if there are 40 ants, the expected is going to be based off of the null. So if the ants truly have no preference, then what we would expect to see is we would expect to see the same number of ants at each food because they don't care. Well, if there's 40 ants and there's 4 foods, that means we would expect to see 10 at the honey, 10 at the banana, 10 at the grapes, and 10 at the lettuce. Okay? So again, null and expected are linked together. Our observed values, let's say that we actually saw 3 at the banana, 15 at the honey, 17 at the grapes, and 5 at the lettuce. Probably wouldn't be 5 at the lettuce, but anyway. And so what we want to do is we want to know, did they have a preference? I mean, eyeballing it, it looks like they do, but we don't know without using statistics for sure. So the formula is observed minus expected squared over expected. So that is going to be 3 minus 10 squared over 10. 3 minus 10 is negative 7. Negative 7 squared is 49 over 10 is going to be 4.9. All right, then our honey, 15 minus 10 squared over 10. That is going to be 5 minus 10 is 5. 5 squared is 25 over 10 is 2.5. Okay, then I'm kind of squeezing in here. 17 minus 10 squared over 10. 17 minus 10 is again 7. 7 squared is 49 over 10. That's 4.9 again, and then this one I'm going to have to do down here. 5 minus 10 squared over 10 is 25 over 10, which equals 2.5. Okay? And you can use a calculator for all that. The last thing we have to do is we need to do this sigma. We need to sum them up. So we're going to sum them up, and that is going to be 14.8. In the interest of time, I did that for us. That is your chi-square value. Because you're running a chi-square test, the test that you're, or the number that you're actually getting is chi-square. All right, we need to get a critical value, but in order to get the critical value, and that comes off of a table we're going to look at in a second, we need to know 2 things. We need to know the p-value. Well, p-value, when we talk about in AP, is always going to be 0.05, unless they tell you different, and I don't think I've ever, maybe once, seen it at 0.01, but almost always it's 0.05. And if they don't tell you, go with 0.05. And then our degrees of freedom. Our degrees of freedom are based on our number of groups. So we had 4 groups. So N is 4. Okay, N is your number of groups. Degrees of freedom is N minus 1. So 4 minus 1 is 3. Okay, now this is where we need this table. So on your formula sheet, so first of all, here's the chi-square formula. You don't have to memorize it. It's right there. Here's the chi-square table. Don't have to memorize it. We want to find, I'm trying to get it out of the glare, we want to find at a p-value of 0.05 and 3 degrees of freedom, our critical value is 7.81. Okay. What we want to do now is we want to compare these two. If the chi-square value is larger than the critical value, and so in our case it is, that tells us this chi-square is kind of a reflection of the difference. So the bigger the value, the bigger the difference. The smaller the value, the smaller the difference. So when it is larger than the critical value, we would then say there is a difference. It's a big enough difference that it's statistically significant, and we would reject the null. Let's say we did all these calculations and it came out to be 2.8. So it was smaller. Then we would have had to accept the null, or sometimes AP likes the term fail to reject the null. That means accept the null. Okay, so this one, again, because it's larger than the critical value, we reject the null. If you have any more questions, let me know. We'll go over some more examples, and I hope that helps.